So last time, we started discussing how to define arrays of pointers. Good? And the thing is, you need to think of arrays of pointers. So until the end of the last lecture, we learned about pointers as just single variables, right? We had dereferencing. Pointers are pointing to our memory locations, which can be an array or any variable. All these concepts, good? Arrays of pointers adds only one slight step towards that, which is I can combine multiple pointers in one array. But the thing that got multiple people confused, and they asked me after the lecture, is if you access an element in an array like bb0, and this is an array of pointers, this now has the array index thing, which is 0. But people don't realize that bb0 is just an array. It's just a pointer. So you can call this pointer1 equal bb0, and then you use pointer1, right? And you have all the pointer arithmetic on pointer1. But you can do the same thing in bb0. So bb0 is nothing other than a pointer. So the thing here is we are defining an array of pointers, which we call bb. It has 3 elements, which each of them has to be a pointer, pointing to integers. And then later what we do is we define 3 other arrays, normal arrays, arrays of integers. And then we make these pointers point, each one of them point to one of the arrays. So bb0 is going to point to array A. This we have done before, but not with the array indices, not with the array syntax, right? We said before int pointer btr, and then btr equal A, right? We had this before. The only difference here is bb0, it happened to be an element in an array, and it's a pointer. Good? So you can say bb0 equal A. What happens when you do this is bb0 is going to point to the first element in array A. Is there anyone still confused? Good? We do the same thing for bb1, bb2. By doing that, now you have the ability to have arrays of pointers, and each one is pointing to a different array. One important thing you need to understand of what is happening behind the scene is this are all contiguous in memory. Why they are contiguous in memory? Yeah? Because this is an array, and arrays are allocated contiguously in memory. Good? But the thing is, this array and any of these arrays are not contiguous in memory. This can be in any address, starting from address 0. This can be at address 0x55f something. Completely like 1 gigabyte away from this address. Why? Because these get defined separately, and the only thing is we link them using pointer arrays, but they are not contiguous in memory. Right? So one difference, a question that I have been asked yesterday is, what is the difference between this and defining a 2D array? Right? This is not a 2D array. Later you will learn in data structure courses that this is called a hash function. You do hashing by saying you define certain things. Usually you put the key here, and each key is going to point to certain data, right? So this is a usage, like the clear use case of such a structure. Is there any question? Okay. So last time we learned 4 different ways to point to an array element, right? Using A, which is the array name, and then the index A0. Or if B is a pointer that is pointing to A, you can say also B0. These are 2 different ways. But also we can do, does anyone have like third alternative? If P is a pointer that is pointing to the beginning of the address of the array, you can do pointer arithmetic. If you want to access element I, then you can say B plus I, right? Which will be the address of element I, and then you do dereferencing, right? And you can do the same thing with the array name A. So here, what we are saying here is that these 3 are completely the same thing, pointing to 2. How this is possible? A1 is very clear. A1 is the first element in the array, which is 2. This one may be the one that is not clear. But if you think in your mind that bb0 is nothing other than a pointer to A, then it will be clear, because BB0 is pointing to A, and then you can point to an array element using the pointer index, right? So BB0, 1 means BB0 is pointing to the first element of this array, 1 is going to point to the first, like the element afterwards, right? And this is equivalent to this thing. BB0 is a pointer. You do a pointer arithmetic, which is +1. This is an address, and then you do the asterisk for dereferencing to take the value, right? So these three things are equivalent. This is not an assignment in C. This is not a C code. This is telling us that these three ways of accessing this element are equivalent. Is there any question here? Good? Yeah?
For, let's say we have B2 and but at the end we add +2 instead of 1. So would it directly access the third element?
Which is 9, yeah. Because if you do BB2, let's say here, one example, oh, we don't have one for, okay, BB2, right? This is what you meant, right?
B3 and the one we have.
B3, this one. So what you do is BB1 is what? BB1 is pointing to, BB0 is pointing to this one, right? Sorry, BB1 is this pointer. BB1 is pointing to 3. If you add 3, then it should point to 6, right? And then you take the value by the asterisk. So this should give you 6, right? No, it doesn't loop through it. It just does a pointer arithmetic to calculate a new address and jump directly to this address. Right? Is there any other question? Okay. So one thing we mentioned about pointers, and the big difference between a pointer, a regular pointer, and a normal array name, which is also a pointer to the first address, is you can initialize an array, but you cannot initialize a pointer by multiple values. Why? Because an integer pointer has to point to an integer variable, but it's just one variable. So you cannot initialize a pointer by having like this kind of array initialization syntax, right? And we covered this in not the last lecture, the lecture before. Good. So now, the normal afterwards step, which is arrays, we have special type of arrays which are strings. Good? So it's exactly the same thing. You can also define a pointer to array of characters, which is string. And then what I'm doing here is defining a character, an array of pointers pointing to character type, right? Then say, S array 0 is pointing to this thing, S array 1 is pointing to this thing, this thing, this thing. Right. So, assume this question is, how do we interchange or swap two strings in an array? How we do this? If I'd like to swap the position of this thing and this thing, can someone mention how we do this easily using pointers? Just the same, like the logic, not the code itself. Yeah. Good. Exactly, but to do this, if you just make this one point to this one, you lost the address of this one, right? So how to do it? You need, what you're saying is correct, but you need one extra step. Yeah, like a temp variable to hold the first pointer. Any swap would require a third variable to basically swap things, right? So what you'd like to do is, by doing the swapping, you define the temp variable, which we call here t. It takes the value of S1, and then you exchange S1 and S2, and then you put the value back in S2, right? Yeah.
Is there any clever way that you can commit using a third variable?
If you can, there is. Think about it. For a bonus mark, let me know next lecture. Okay? Yeah. Why there are 2 stars? That's a good question. And this is almost the most advanced topic in pointers, which you are visiting right now. Why we have two stars here? Good? Yeah. It's a pointer to a pointer, which we call double pointer. Okay? So I told you before, let's take the story from the beginning. You have a normal variable, which is int. You have a pointer that can point to this variable, right? Which holds an address to this int. Good? But at the end, a pointer is nothing other than a normal variable as well. So it's stored in memory, right? That means you can take the same thought further and say, I can have a pointer that is pointing to this pointer. And even you can say, I can have a pointer that is pointing to another pointer, etc., etc., right? And this is the concept behind what we call linked lists. This is also another data structure that we'll cover later, is you have links. You guys heard about blockchain? This is like another fuzzy new concept. It's a very similar thing. You have one block of data, and then the way you validate this data is you would like to also connect it with the chain. This is what we call blockchain. So think of linked lists as the same concept. You have a block of data, a block of data, a block of data, a block of data. They are distributed in memory. They are not contiguous like an array. But the way they are linked is each block has data and a pointer to the next element. So once you have one element, once you can access one element in such linked list, you are able to traverse the linked list using the pointer, because you have a pointer that is pointing to another pointer, pointing to another pointer, etc., etc., etc. Right? Just put this in mind. We'll visit this later. Good? Okay, so this is how things work. Now, what does the name of a pointer array represent? And this also related to his question. Previously, we learned that the name of the array is a pointer to the first element, right? But what does a name of the array of a pointer represent? The same thing. It's a pointer to the first element of the array, but it just happened to be a pointer as well, right? So you can say BB is actually the address of BB0. BB0 is a variable, has a value. It happened to be a pointer, but it can be anything. So the concept still applies, right? So BB is a pointer to a pointer, or what we call double pointer. And this is why in this function, we had this double asterisk things, because you are passing a pointer to a pointer, right? Is there any question? Okay. So a double pointer is a pointer to a pointer, and then if you define, as I said, if you define a variable int a equal 100, and then you define a pointer to this variable, you take the address, which means B is pointing to here, but also you can define a pointer to a pointer using this double asterisk thing to make this pointer point to this one. All right? Yeah.
Is there ever a point where like the pointer to a pointer, like it gets confused in its own mess where it can't actually handle the amount of pointers that it needs to go through?
That's a good question. So maybe I'll ask the question in a different way. Does that mean if I want to make a pointer to this pointer, I need int asterisk asterisk asterisk, 3 asterisks, and then 4 asterisks, and like, right? No, right? Why this is the case? Because what really matters is what you are pointing to. Assume here I have a fourth one that I call BBB, and I want BBB to point here. What matters is what is the type of the variable that you are pointing to. Remember we said for a pointer you have to determine what is the type you are pointing to, right? So if your type is a normal variable, then you just use this asterisk thing to say I'm a pointer to an int. You use double asterisk to say I'm a pointer to an int. Good? Here, you can say I'm a pointer to a pointer. What is this pointer is pointing to? Later it doesn't matter. This pointer has to care about himself, right? But what I'm saying is 2 asterisks are enough in all cases, because what matters is what you point to. What is the chain is about, it doesn't matter, right? Is there any question? Good? It's getting more funny. So if you have questions, let me know. So here, if, again, this is dereferencing. So the value of B equal A, which is 100. The value of BB is what BB is pointing to, which is this B, which is the address of A, which is this thing, right? And then if I do double dereferencing, then what you are doing is, think of this like this. You are doing the value of BB, which is the address. You can replace this with B, which is the value of B, and then at the end it's A. If you do double dereferencing, you go to the original value itself, right? Is there any question? Good. So if we go back to our original example, BB, the name of the array of pointers is a pointer to the first element, and this is originally its value. If you do dereferencing for this name, it gives you the first element. If you do like double asterisk, which is double dereferencing, then it's like you're doing a dereferencing for the first element, which gives you A0, right? This is exactly the same previous slide, but it happened to be one of the pointers is just an array element, right? So combining arrays with pointers to arrays seems complex, so you have to try it yourself. And like, I also post some exercises, I forgot to say this. So I don't know if some of you visit already the sample questions or sample practice questions that I post in Avenue. And after some time, I also post their solutions. This is also another way to practice things, because sometimes the lab is far behind the lecture, especially after the reading week. For example, we are starting lab 3 after the reading week, but we already covered pointers and we'll move to another topic. So tomorrow in the tutorial, the TA will cover arrays and functions, but also he will cover pointers. Good? So if you feel you need to practice before you forget the concept, maybe it's better idea to go to the tutorial. We discussed allocating memory last time using dynamic memory allocation. What if I would like to dynamically allocate 2D array? Something of that sort, similar to the example we covered, is you have an array of pointers, each one of them is pointing to another memory location. And I can access this using BBIJ, similar to the example we had. Good. How I can do this? Someone can imagine what would be the logic for a bonus mark? This also was intended to be a quiz, but I just went back. So if someone can think of how I can dynamically allocate a 2D array using such concept for a bonus mark. Yeah. Will you say this? Yeah, yes, for sure you use the malloc function, but how? What is the logic? This is M, and each one of these has to point to an array of n elements. And then you will allocate the whole chunk at once, m by n. So think in this a little bit. This is what I am asking for, basically. How you would allocate this whole chunk of memory, including this and all of that. Am I going to allocate this as whole chunk, m by n? But these are not the same size. This is different than this, right? This is the double element, but these are pointers, right? Good. That's the right way. So please give me your name afterwards. Yeah. Exactly. This is what he was saying, but in different language. So the thing is, for each element of this array, you have to do a for loop and do a malloc, right? Because for each element in the entry, you want to allocate n chunks in memory, and each one of them is double, right? So you have to do a for loop through this array, then each time you do a malloc. Good. So you read m and n from the user, and then mni, and then this is the float of the array, which is this one. So I can write it like this, which is a pointer to the first element, or I can write it as an array structure. But why I didn't write it as an array structure? Because I don't know the size of the array, right? And this is the neat thing about dynamically allocating memory. You just need a pointer, and then later you allocate whatever size you'd like to do. Right? So let's see. First of all, I'd like to allocate the first array, which is the array of pointers. This one has a size of m. And I know that each element is a pointer to a float. So the way I do this, from last lecture, you allocate m multiplied by the size of one entry, which is the size of a float pointer. Yeah.
Sorry, I'll ask after.
Good. Then we allocated this thing. Now, it's time to allocate the remaining ones. But as he said, you need a loop to loop through these things and then start allocating it. Because the thing is, you need the malloc. You remember the malloc returns a void pointer to the first address. You want the allocation of this memory location to return to you the pointer of this address and place it in the first entry of that array. And here is you create the link between this array and these ones. If you just allocate it anywhere in memory and you don't return the address to this memory location, such connection will not exist, right? Malloc returns to you only one thing, which is a void pointer to the first segment of the allocated memory. You need to place this in the pointer array to create such a structure. Good? So you do a for loop, and then you take the result of the malloc, which is each one of them is size n, and you put it in BBI. So by this line creates this connection after creating the n ends. What was your question?
For the allocation of this, would you need to run to the for loop, or would you just deallocate the head?
Good. You have to first, and we will come into this. So I don't know if you were the one who asked this question yesterday or someone else. But someone asked me, do I have to, like I said, you have to free memory for yourself, right? But someone asked me, if malloc didn't succeed, what will happen? Does it free the memory for me, or I have to see what was allocated and free it? Now, because you do each of these malloc things separately, I can encounter the case, and focus on this because this is important. I can encounter the case that the compiler is executing my code. I allocated the first array, good. I go through the loop, allocated this, and the third one, I found I don't have enough memory. What would happen? You created this and these two, but the remaining ones cannot be created. What should I do in this case? The third malloc, because it didn't succeed, it will free itself. But these two are already allocated. This array is already allocated, right? So you have to write your logic to say, if everything didn't succeed, then you have to free everything that has been allocated. Right? This makes sense? So another way of doing things is, instead of doing this loop with malloc for each entry, you can, in reality, allocate all these things as one chunk, and then make each pointer of this is pointing to like the n size thing. So instead of allocating different n segments, you can create one total m by n segment, but then each of these pointers has to point to 0, n, 2n, 3n, 4n, right? So if you imagine the memory is just contiguous byte addressable space. You can either allocate these things separately, or you can allocate them at once, and then you point to them differently, right? So this is another way of doing things. You just have m by n entries, and now you make the first pointer is pointing to 0, the second pointer has to point to n, the third pointer is to 2n, etc., etc., right? What is good about this thing? Someone else? It's a bonus mark. Yeah. Would you please raise your voice? Would you say this again? I don't hear you. Okay, so say it again. It uses few CPU cycles. No. That's not true, because it does exactly the same operation. It allocates the same number of memory locations, right? Yes, okay, that's something important to discuss. Good. Maybe it's not the topic of this course, but let's go through it briefly, right? What he is saying is I'm doing this as one step. Oh, this is working for me, that's great. So I'm doing this as one step. On the previous slide, I was doing each one at each iteration. If you look into the two amounts of work, the only difference is what? The only difference is that logic checking at the for loop, which is minimum. It's almost negligible. No one takes into account the condition because it's just one cycle or two cycles per iteration. So absolutely you are correct, but from a practical point of view, it doesn't really matter. Okay? Yeah. And what is the benefit of that? Yeah, that's one. Yes, that's absolutely one thing. Actually, this what I didn't have this in mind, but that's correct. These things are contiguous in memory. That means you can access them faster. Good. But another thing that is related to what we just discussed right now. Yes. That's true, but it's even further than this. Yeah. You don't need to free them, right? Because it's just a single malloc operation. I told you that in malloc, if the allocation didn't succeed, it just free itself. Previously, because you had separate, because here you had separate malloc lines, each one of them is completely independent, right? But here, in this case, you have only one malloc operation for everything. So if there is no enough space in memory for everything, frees itself. You don't need to care, right? But one disadvantage of this thing, and this is like for 2 bonus marks. Yeah? Maybe we need to use this mic. Yep. Okay, some exercises are okay. Yeah. No, they take the same time. Okay. 2 bonus marks. What is a disadvantage of this thing compared to allocating every array separately? Yep. The memory is? May not be big enough, but you still need, you're in the right direction by the way, but you still need the same amount of memory here. No, but the program is asking you to allocate all of that. Yeah? Here? Yeah, it's here. Any pointer can access everything. That's correct. But is that not correct here? Starts not working, okay. Is that not correct here? That's correct. Yeah, but this is not the reason that I had in mind, but yeah, these two bonus marks. But also again, it's related to the same reason that you said. Yes. No, but I'm allocating the exact size of memory I'm allocating here and here, right? So, okay, I'll just give a hint, and then it will be only 1 bonus mark. As he said, this is contiguous. This is not contiguous. Yeah? But that's an advantage, right? Not a disadvantage. Yeah, what I was saying is what is the disadvantage of the second one? Yeah. But that was related to the previous question, so also please give me your name afterwards. This is another advantage of this one. Yeah. Exactly. So here is the thing. I'm allocating the same amount of memory. But in this case, this has to be contiguous. Think of your memory as one big 4 gigabytes, your DRAM, right? Things are running on DRAM like the operating system, other applications are taking different places in memory. Most probably you don't have 1 gigabyte contiguous in memory free. But you can have different chunks that can add up as 1 gigabyte, right? In this case, if you don't have, assume this size is 1 gigabyte, if you don't have a contiguous 1 gigabyte in memory, this is going to fail. But if you have 1 gigabyte of memory that is not contiguous, like 500 kilobytes here, 500 kilobytes here, and then they add up as 1 gigabyte, as given it's enough to allocate for one array, this will work, right? Why? Because this and this doesn't have to be contiguous, right? This is called, can someone know the name of this thing? Did you hear about this before? It's an important terminology used in both hardware and software. It's called memory fragmentation, right? So this is a good thing to know, right? Memory fragmentation means you can have enough memory space, but it's not contiguous. So if you need the contiguous one, this doesn't help you, right? Okay. For those who took bonus marks, please give me your name afterwards, because people, I don't know why they lose their bonus marks. They answer questions and they don't come to me afterwards. Okay. Great. So how to do this? This is really very easy, because you just allocate the size of this array, then you allocate the whole chunk using only one line of code. But what it remains, you need a loop to make each element here point to the correct place. How to find the correct place? It's time over. Okay, why you guys talk? Because I used that you talk at like 11:20. And this is how I know that the lecture is over. We still have 5 minutes. Okay. So how to know the right place to point to by each pointer is by doing this arithmetic thing. You have a variable that is q. What is q? Q is a void pointer, or now it's a pointer to a float, which takes the first element. And later you have to increase this by I multiplied by n, because you need to jump n steps, right? The first one has to point to 0, the second one has to point to n, 2n, 3n, 4n, right? So you create a loop, and then this arithmetic is giving you the correct address. Is there any question here? Again, what we are doing, we are trying to allocate a 2D array using different ways, right? Okay. If we take this concept further, why I don't make this array also on the same contiguous place as the remaining ones? This is just a normal array. So what you can do is just allocate everything together, right? You don't need now to do 2 mallocs. For the first example, we had how many malloc instructions? We had 1 and then m ones. So we had m plus 1, right? In the second one, we only had 2, right? In the third one, you only need 1. But what would be the size of this malloc that takes everything together? What would be the input to this malloc function? You need m by n and then this thing, right? The only problem with this is now this is no longer an array of pointers pointing to arrays, right? This is considered just one chunk, and each one of them is just a separate element. Unless you define another pointer that is pointing here, consider this as an array, right? So how to access these elements? We have 4 different ways. We just lost one way, you can use the other ways, which is doing dereferencing using pointer arithmetic. So to access element, which one? Like to go to element j in array n, what you can do, I guess this is array I, you can say I multiplied by n to jump to array number I, and then plus j to access j element in this array, right? This is equivalent to the previous example of bij, right? You can try this example at home because it gives you an understanding of pointers, arrays, and how things work. Good. So I told you one thing is, because in the first example, we allocate each array of the M1s separately. If one of them failed, you have to free whatever has been allocated before, right? So what you do here is, this is like almost a complete solution using also the checking whether the memory is allocated or not. So what we do, we define an error variable, assign it to 0, and then here we are using calloc, but you can use malloc, it doesn't really matter. And then I'm doing if condition here. So what does this if condition do? I told you previously, if malloc or calloc failed to allocate, it returns a null pointer. And if null is completely equivalent to F0, right? So this is how to check whether malloc or calloc succeeded or not. If they return null, that means they failed. And then you say printf not enough memory. You already failed. Good? And this is for the first array, which is the array of pointers. And then afterwards, you do a loop. You try to allocate each array separately. And you do the same check. If it fails, what would happen? First of all, you have to break, because there is no need to try to allocate more. You already failed to allocate. But also, you need to make an error, you need to make a flag that I failed at one step to allocate required memory. Why this is needed? Because once you exit your for loop, if you succeeded to allocate everything, then the error would remain 0. And in this case, great, you succeeded. But if error has happened to be 1 at any loop, then that means you failed. If I failed, I don't have enough memory, but what do I need to do in this case? You need to free everything that you already allocated, right? How would I know what I have been already allocated? This will